In this problem, what we're trying to do is find the formula of a hydrate. A hydrate is an ionic compound, in this case, cobalt 2 chloride, COCl2, in which case inside the crystal lattice is located a certain number of water molecules, a certain number per every mole of cobalt 2 chloride, and that's what we want to find. We want to find what that number is. It should be some whole number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, could be even higher than that. So what I need to do is basically find the ratio of number of moles of cobalt 2 chloride to number of moles of water. The data that I have is enough to find the grams of water. If I know I start with 11.75 grams of the hydrate, that means with the water in it, and then I heat it up, and I have 9.11 grams of the anhydrous left over, the difference in these two numbers should be the mass of the water. And so therefore I find that I must have had 2.64 grams of water inside that crystal lattice. If I take that 2.64 grams of water and convert it to moles using the molar mass from the periodic table, I get 0.1465 grams of water. Now I want to compare that to the number of moles of cobalt 2 chloride. I know that this, my anhydrous cobalt 2 chloride, is the grams of that without any water. So 9.11 grams, and convert that to moles. 1 mole is 129.83 grams. Again, I get that number from the periodic table. And then I got 0.07016. And that's going to be, this is not grams, this is moles. This is going to be moles of COCl2. And what I wanted to do was find the ratio of those two numbers. So I take the moles of water over the moles of COCl2, 0.1465 over 0.07016, and this should be a whole number as well, and I get the whole. So I get the whole number 2, and that means that the number of water molecules for every mole of cobalt 2 chloride is 2. And the formula of my hydrate is COCl2.2H2O, or cobalt 2 chloride di, the prefix di meaning 2, hydrate.